8.5, solving exponential equations. We know how to use exponential equations. There's not much log happening in this section. We do use log to possibly solve if we want. We don't need to. We can approximate without log. But you're gonna see some things that you've done already, especially like half-life, compound interest formula, and maybe some stuff you haven't seen before. So first example is a half-life equation. Mr. Spenceri received a shipment of 200 grams of radioactive radon. And 16 days later, 12.5 of the radon remained. What is the half-life of radon? So recall our formula for radon. If I'm asking you this on a test, probably gonna give you the formula. It's also right up there. So we're gonna plug in all the things we know. First of all, M with subscript F is just the final mass, and this is the initial mass with the I. Total time and half-life, we have to solve for half-life. We have to solve for the denominator in the exponent. Kind of annoying. Okay, but let's plug in things and see what we get. So we have 200 grams to start, so my initial is 200. 16 days have passed, so time is 16, and I don't know what the half-life is. I'm gonna call it X. I do know that in 16 days, the final mass is 12.5. So this is everything I've learned from the question plugged in. And now I have to solve for that unknown exponent. So I'm gonna divide by 200. That's wrong. Okay, so when you're in a position like this, you can just change that to a decimal if you want. You can reduce it to a fraction. If you have an ES calculator, I think it's 1/16, let's just check. Yep. Could reduce this if you see it available. Again, when you see things that are available, the work becomes easier. You have easier outs, you have more accurate outs. If I turn this to a 1/16, I can match the 1/16 and the 1/2. There's no reason to use log or estimate. I can say, well, this is a 1/2, and from 8.4 we did that 16. I know it's 2 to the 4 to the 4. Now I want to match these bases because when these are the same, these must be equal. So now I can just say, well, I know that 4 must be equal to 16/x. And I can switch these guys, multiply by x, then divide by 4. X is 16/4, so x must be 4. Therefore, what is the half-life of radon? The half-life of radon is 4 days. Or, from even this point, say I don't want to do anything with the 16th, I don't know what 12.5 or 200 is, no problem. You can find the log of both sides if I have enough space here. Log of 12.5/200 equals log of 1/2 to the 16/x. And just take a look at what this does. Log loss tells me that this 16/x, this exponent, I can bring down in front. We learned that in 8.4. So this becomes log, I'm just going to turn this to a 1/16 to make it cleaner. This is going to be 16/x times log of 1/2. And I'm slowly trying to get to this x over here. So I can get rid of this log of 1/2 by dividing on this side. So this is log of 1/16 divided by log of 1/2. This equals 16/x. Plug this into your calculator. I'm certain it's going to equal 4 because math don't lie. And I can get 4 equals x. But what? I mean, yeah, if I'm stuck in a corner with absolutely no outs, of course I'm going to use this, but this is beautiful compared to that. Okay, but you choose your poison, whatever it is. We get rid of this so it doesn't leak. Okay, we also have to be able to solve exponential equations when there's multiple terms, right? Not just a monomial. Monomials are kind of easy, and then eventually they're not. So we have the same base here. What I can do is I can factor out something. Okay, I can factor out something that they have in common. We did a little bit of play with this yesterday. So if I factor out something in common, that's a 2 to the x. Now, if I get rid of a 2 to the x from here, I'm left with a 2 to the 2. And if that confuses you, when I factor something out, 2 to the x plus 2, I'm really dividing it by 2 to the x. So this is going to be 2 to the x plus 2 minus x, which is just 2 to the 2. Okay, just recall exponent laws, even with equations in the exponents, the same thing. You're still adding and subtracting based on the operation. This becomes a 1, and that's a 24. This is a 4 minus 1, that's a 3, and that's a 24. I can get rid of that 3, 2 to the x is 8. Now I can do that same thing, I can find the log of both sides, but I know that 8 can be turned into a base 2. So I know 2 to the x is 2 to the 3. I'm turning that 8 into a 2 to the 3. Therefore, x equals 3. And not too much damage there. I got out pretty easily. Okay, let's just jump over here just so we're in the same kind of mindset, because it looks similar, but it's very kind of different how to approach this question. We don't have the same base here. I can't factor out a 2 to the x. I love doing this when I see same bases because it's easier. When I don't have the same base, I have to bring down those exponents because I can't solve for that unknown exponent. So in this case, I have to find the log of both sides. So if I find the log of both sides by doing this, it's going to bring the exponent down in front. Make sure you put in brackets, or else it's going to be a -1 log 3, and then that x is separate. It's got to be in brackets. Still nothing I can really do if I divide by the log 2 or 3. There's still x's on both sides. So in this case, I have to distribute inside these brackets. So this is going to be x log 2 plus log 2 equals x log 3 minus log 3. Okay. When in doubt, just math. Just do stuff. Okay, now I know from experience I got to bring all the x's to one side, right? I can turn log 3 into a decimal using my calculator, but that doesn't make any sense. Just keep it as a log 3. Pretend it's a number. Ignore the letters. So I'm going to have an x log 2 minus x log 3. And on this side, I'm going to have negative log 2 minus log 3. X is on the left, non-x is on the right. Now I can factor out an x. And I can see that developing and isolating that x. So if I factor out an x over here, you know what, I'm going to factor out a negative over here too, because I don't like looking at too many negatives. Okay, I'm just factoring out that negative. My experience when I divide and I have fractions, errors occur if I don't do that. Now I can just get rid of this by dividing. So x equals negative log 2 plus log 3 over log 2 minus log 3. Calculator work. Highly recommend you all try this. There's a lot going on over here. Brackets, depending on your calculator, how you do it. You might have to put this in brackets. Depends if you have an ES or an MS calculator. Try it out. So I'm going to put negative, open bracket, log 2 plus log 3. I'm just going to hit equals because I don't want to confuse myself. And now I'm going to get that answer and divide it by bracket log 2. I don't have a common log button easily available. I have to keep putting the base 10. Kind of annoying. Minus log base 10, 3, close brackets. Syntax error, obviously. 4.419. 4.419. 3 decimal places. I'm good. Pretty difficult to be able to do that with trial and error, especially when x is in multiple places. Okay, so use your log laws to bring down your exponents and then math out. Okay, one more question, something we've seen before. Compound interest. We have an investment of $2,500 that grows at a rate of 4.8% per year, compounded annually. Luckily, it's annually, not much to do. How long will it take the investment to be worth $4,000? Here's your principal, here's your interest rate, here's how long it's being invested, or more specifically, how many times it's being compounded. And this is your amount, which is your total amount in the future. Okay, so similar to this, MF, MI, this is like PF, PI, if you want to call it that way. When will this be 4,000 if I invest 2,500 at 1 plus 0.48 how long will it take? I need to find the exponent n. Same idea. I can add these inside here. I can divide by 2,500. So 4,000 divided by 2,500 is 1.048 to the n. I just added them. We can get rid of some zeros there. 40 over 25 is 8 over 5. Is that going to help with anything? I don't know. I don't know unless I plug it in. I could just change this to a 1.6, and then I could just play around, be like, hey, when am I going to get a 1.6? Maybe it's going to take me 20 seconds to figure that one out with a calculator. Trial and error. Okay. But we don't like doing trial and error. I am going to change this to a 1.6 just so we're in one line. So I'm going to find the log of both sides. Log of 1.6 equals n log of 1.048. I don't really show this step anymore when I find the log of both sides. I actually bring down the exponent in the same step. And now I have to divide by the log of 1.048. So log 1.6 divided by log 1.048 equals n. Calculate that up. So log base 10 of 1.6 equals, divided by brackets, log base 10 1.048, 10.02. So n equals 10.02. So for 2,500 to turn into 4,000, it's going to take just over 10 years. Know this step. You chemistry guys have an advantage here. You've used it before. Finding the log of both sides to bring down an exponent. Very useful.